Welcome back again to the Ivory Tower Collections. We're in the lab today, and today's video is going to talk about this. This is one of several different types of boards that can be installed as a new video upgrade in many classic retro consoles and computers. It's developed by a very talented coder who goes under the name of Copper Dragon. And specifically, this new video upgrade is referred to as Lumacode. Now, what Lumacode basically allows us to do is to take a simple video signal that gets converted from the console that is then able to be converted and provide us with an HDMI output that looks fantastic on these systems. So in today's video, I'm going to go over just the very basics of Lumacode. I'm going to go a very little bit into essentially how to connect up and utilize a complete Lumacode setup, parts that are needed, and I'm going to go through some of the very basic menu functionality that might be necessary to get the best enjoyment out of a Lumacode setup. So let's get to it. So what do we need for Lumacode functionality and upgrade to work? Well, we need a digitizer board, such as this one here. This digitizer here is specifically for use with the Mattel Intellivision consoles, both the Model 1 and the Model 2. But there are digitizers for lots of other systems as well. As examples, there are digitizers for the Atari 2600. There's another digitizer that can be used on the 5200 and the 8-bit computers. There's even a digitizer that can be used on the ColecoVision and the original Nintendo Entertainment System, or NES. So what is a complete setup? Well, again, we have to have the digitizer board like we have here. This would be installed internally inside of the console or computer that supports it. We also need the other big part of the brains of the operation, and that's this box right here. This is called the RGB2HDMI. It's actually a project that's been around for a while, and as the name implies, it was originally designed with the intention of taking analog RGB signals and outputting a HDMI digital signal. This particular version of the RGB2HDMI is running a very specific version of the board that's designed to handle this Lumacode video standard. In a nutshell, think of the RGB to HDMI converter box. It's basically a video upgrade ecosystem similar to, say, like a RetroTink or other scaler device, except in this case, this is very purpose-built and designed to take in very specific signals. This will provide you with a full-scale HDMI resolution output to whatever resolution your monitor or display you have it connected to supports, which is fantastic. We'll talk about the RGB to HDMI converter box in a little bit more detail a bit later, but you need to have this box here. In addition, you're going to need a way to get the new video signals from the console to this RGB to HDMI box. And in this particular instance, the particular version of this RGB to HDMI is designed with a single 3.5mm TRRS jack, like a stereo headphone jack. So in this particular case, you're going to need some sort of a cable to plug into that TRRS jack, and again, it just needs to be a standard stereo type cable. The reason for that is because this particular box can handle not only Lumacode, but also mono audio from a console and mix them together. And then on the other end, you would either have another 3.5mm jack from the console itself that's providing your video and audio, or you might have something that might use separate RCA jacks, such as this cable set up here. And many of these RGB to HDMI boxes, if you get the ones that are already preset to be able to handle audio, some of them come with this little short 3.5 to RCA breakout cable that you can use. So you could just use RCA jacks or even possibly repurpose jacks on a console to provide the audio and video you need and then plug it into the RGB to HDMI converter box. But the RGB to HDMI converter box doesn't work on magic. So it's also going to require power. And specifically, it is powered using a micro USB cable. That's because the RGB to HDMI is powered with a Raspberry Pi computer inside of it. Now, the particular ones I've been working with are just using Raspberry Pi Zeros. Those are one of the cheapest versions of the Raspberry Pi. But the Raspberry Pi has two micro USB ports on one side of it, and the one that's furthest to the side is the one that is dedicated primarily for power. But you can use either port to power the Raspberry Pi. So it will need a separate micro USB cable to power it from. In this case, I've been using a micro USB to USB Type A cable because I can either use a decent quality phone charger that uses a USB-A type connection on it, or I can just plug it off the side of my TV, which is what I've been doing most of the time, is just been powering this from my television. So yes, this would also need power. The other thing is the output. Where are you going to get the output? Well, this does provide HDMI, but again, due to its small size, it uses the mini HDMI output format. So in this particular case, I've got this real simple little mini HDMI to full HDMI adapter cable. I've been using these. They're very good cables. I like them a lot. And that will just plug into that. Okay, so those are the full set of parts that are required for a complete RGB to HDMI setup, and in this particular case, specifically for use with Lumacode. There is one more thing that you also need if you're kind of piecing this together yourself. You'll notice there's a little piece of yellow tape I have here on the side. That is because I have that taped around a micro SD card. There is software that you can get online from the RGB to HDMI and from the Lumacode GitHub section, and I'll provide a link in the bottom of this video where you can get that. But basically, you just have to format a micro SD card to FAT32, just copy those files directly to the root of it, and when you insert it into the side here, which again is for the Raspberry Pi, then it will provide everything the Raspberry Pi needs to boot up and load and operate. Right, well that's pretty much it. This particular version of the RGB to HDMI I purchased from Copper Dragon's website because it was pretty much all ready to go. He also sells these 3D printed case shells to house everything into. He's got them both available in white and black. What are these buttons about? You've got a dedicated button that accesses an on-screen display menu to change different configurations and settings within the RGB to HDMI box. And then you have two additional buttons here labeled as SW2 and SW3. Those are for toggling between the different options. And then you have a reset button here, which, as the name would imply, resets the RGB to HDMI, essentially like a soft power cycle. Let me go ahead and take the cover off of this so we can get a little bit more of a look on the inside of it. The top portion you see here is the main portion of the RGB to HDMI, and this is bought separately. And this particular one has an audio board installed already ahead of time. That's because normally the RGB to HDMI doesn't handle audio. So with this little add-on board soldered into place, it allows it to capture audio and embed that into the HDMI output without having to use a separate external mixer for that. Let me go ahead and take the RGB to HDMI out of here, and we can see what's underneath. And what's underneath is the Raspberry Pi Zero. This specifically is a Raspberry Pi Zero 1.3. Again, this is one of the cheaper Raspberry Pis you can purchase. And that's pretty much it. What I'm going to do now is I'm going to switch the angle of my camera around, and I'm going to point it over to a portion of my lab here where I now can test bench consoles. I will go into more detail showing you how everything connects up with a console, and then we'll go through some of the more common menus that you will need to know about so that you can navigate, make configuration changes, save your changes to the different profiles, things like that, just to familiarize yourself with the operation of how to use the RGB to HDMI. So, we'll be right back. We're now situated here at the lab, and I'm going to go over some of the basic menu options and features that you're likely to need to use on the RGB to HDMI box with the Lumacode setup. In this example, we're going to start with this Intellivision console that I already have a stick digitizer installed into. So as a refresher, this particular console has one of the 3.5mm audio jacks installed that provides the video and the audio from just this one little port right here. So all I need to do to get things going here is to just plug in some power, turn it around. This is the 3.5mm audio cable that goes from the RGB to HDMI converter box that I'll be plugging into that port on the back of the console, just like that. I've got my back bit cartridge here that's got the Intellivision adapter in it. We'll go ahead and get that inserted and get that ready to go. And we should be ready. So I'm going to go ahead and power on the console. I do have everything connected up. Again, that audio cable goes into the side of the RGB to HDMI to provide the video and audio signal to the device itself. And then I have power from the RGB to HDMI supplied by a micro USB cable plugged into the side of this monitor here. And then I have my mini HDMI to full HDMI adapter cable here that just provides the full actual HDMI connection to this monitor. So let's power it on and see what we get. Okay, it looks correct in that we can see it, but I happen to know the colors are not right, and that's because this is currently on the wrong profile. Again, it supports multiple devices. So the first thing I'm going to show you is how to change the profiles. So again, there are three main buttons that you'll be interacting with on the device. The first one, marked SW1, is how we enter the menu. It also doubles as like a return key or an enter key. We also have SW1 and SW2, which are used as essentially up and down or left and right, basically to switch and toggle between different options. So I'm going to push SW1 first to activate the menu, and I will have I will overlay the direct capture from this to help see this better. And currently, if I take a look at the profile option here, it says that I am currently selected for the Atari 2600 Lumacode. That's because I was previously testing and using an Atari 2600 with this setup. So all we need to do is to scroll down to the option for select profile, and then I'm going to use the SW1 key again, and then I have my choice of systems to choose from. This happens to be an Intellivision, so we're going to go to Intellivision, and then I'm going to choose the option I have here for Intellivision Lumacode 60 Hz. That's because Lumacode profiles do exist for PAL systems as well. So now the system's going to reboot itself and reset, and now we are in the Intellivision profile. It defaults back up to the return option, so I'm just going to leave it alone. Now the colors look correct, so it actually fits everything on the screen pretty well, but I would prefer to maybe not have quite as much cut off on the sides. So let me show you what I can do to fix that. Again, I'm going to hit the SW1 to go back into the menu, and I'm going to go into the Preferences menu. And the first thing I'm going to change is in this option here called the 16:9 integer scaling. It defaults to enhanced 4:3, and I'm going to change that to exact 4:3. Now the only problem with this is that now I have the complete image, but I've got massive borders all the way around, right? So there's a couple of different things that we could try to look at on this. One of the options is I can go in here and try to change the resolution. Now by default, the RGB to HDMI is normally set for what we would call an auto mode. So I'm going to choose it to that here real quick. I'm just scrolling through. There's a whole lot of different preset resolutions that you can force it to come up into. Okay, again, I'm going to leave it on auto. Now what auto will do is the RGB to HDMI, when it reboots itself, using the EDID information that it reads from your monitor or from your television, it will determine what it thinks is the best full screen resolution to use. Now anytime you change the resolution from the RGB to HDMI like this, it will require having to reboot the device. So I'm going to hit return, and it's going to tell me that it's getting ready to reboot. If I go into the geometry menu, another thing we can do is we can change what's called the offset. So the offset allows us to essentially move the image left and right a little bit. So that's another option. If it doesn't quite line up, or if you find that the image is shifted too far over to one side, that's something you can do to try to address that. So, you know, honestly, for the most part, at least for the Intellivision side of things, on this particular monitor, this is probably about the best I'm going to be able to get. It's also possible that there might be options on the monitor itself that I might be able to change to alter this. But as long as I can see all of the characters the way I expect, I'm okay with this particular setting. Another thing we can do to kind of test this is I'll power off the console really quick, and I'll bring it up into diagnostic mode on my backbit cartridge. There we go. And this is another good way to make sure I can see all of the graphics properly. I do see a little bit of extra over here on the right-hand side, but it's really not that big a deal. The main thing is I want to make sure that on the version information that the V isn't being cut off at all. And it's not, so I know that everything is good and everything should fit on the screen properly. So again, just to kind of refresh really quickly, SW1 accesses the menu, and one of the most common options that you're going to have to use is the one for selecting the profile. Again, that's going to be very common to have to choose that option just to be able to switch between different systems. Once you're in a particular system setup that you like, it's not going to be unusual to have to go into the geometry menu and perhaps have to set with the offsets and some adjustments there. Let me change consoles out to another console that we're pretty familiar with that's going to require a little more tweaking, just to give you an example of one of my more extreme cases that I have to deal with sometimes. Okay, so now I have my Atari 5200 hooked up, And just like before, I've got power and I've got the little 3.5mm audio cable plugged in to a 3.5mm audio jack that I've installed in this console. It is plugged into the RGB to HDMI. You can just kind of see it slightly peeking up over here in the corner. And I've got my backbit cartridge with the 5200 adapter in, so let's turn on the 5200 and see what we get. And we have an image. I can see the text, but this is clearly not correct. So what's going on here? Well, remember, we were previously looking at the Intellivision. The RGB to HDMI remembers the last profile that was used. So first thing we're gonna have to do is we have to change the profile for that of the 5200. So again, I'm gonna use SW1 to access the menu. I'm gonna go down here to select profile. It's at the bottom of the list. I'm gonna use SW1 again to select that. And this time I'm going to select the option for Atari, enter on that, and now I'm going to move down to the Atari 5200 Lumacode option, and I'm going to select that. And now what's going to happen is it's going to basically reset itself, and we are now loaded back up with the 5200 profile. At this point, it looks a lot better. The colors for the backbit menu look correct, the text is correct, but there's still something a little bit off. If you take a look up here at the top of my selector bar, this is obviously not correct. What's going on here? Well, again, the 5200 is kind of an unusual case in that it's one of the consoles that I find that I have to go in and make other changes for. See, I just backed out of the menu one, and all of this has kind of got this weird flickery thing going on. So let me show you some of the slightly more advanced options that you may have to tweak on a console by console basis specific to your TV. So the first thing I'm going to do is to fix this weirdness. Again, I'm going to go into the menu options by hitting SW1, and the first thing I'm going to do is I'm going to choose the option called Sampling Menu. Now, one thing you may have noticed, you probably can't see it on the screen too well, but you'll see it on the capture that I'm going to overlay, is that as you change different profiles, these menu fonts will also change to match. So as it turns out, with my particular 5200 setup on this particular display, these are the two items I have to change to correct the weird video goofiness. The first thing to do is to change my sampling phase. It defaults to 6, but I actually have to use 7. Now that gets me real close because as I made that change, already some of that weirdness in the background disappeared, but there's still some little sparklies or some little black pixel dots that kind of show up intermittently. And that's because the next option I have to change in this particular case is the option for the DAC-A voltage adjustment. And in this case, I actually have to lower it to 0.61, which only applies a 0.79 volts on this particular DAC setting. When I exit back out to go back to the menu, I'm just going up to return, hitting menu. We can now see that I have a much more stable image. It looks as I would expect. Another thing that I wanted to show you, although it's not 100% accurate on this, so I purposely have knocked the phase off of alignment here for the 5200 console because I want to show you a feature that can help to get some of these little sparkles and things like that fixed up for you. If you press and hold down the SW3 button, it will enable an auto calibration feature where the RGB to HDMI is basically going through each of the sampling phase options, and it tries to find the best one to fit your needs. And you'll notice it has this little error counter. That's because it's actually scanning the image and it's determining if there's artifacts in that image. And it went back to choosing phase setting 7, which was what I had it on before. It likes that one and it agrees that that's where it needs to go. But you can see that it automatically picked up on that and fixed that. Now I have to state that that auto phase adjustment will only work well if you have a completely static image on the screen. So title screens that have cycling colors, obviously a gameplay screen or the game and demo mode, those are not going to work. You really need a static screen. In this particular case, the menu from the back bit was perfect for this. So let me show you something else kind of interesting. Let me load up the game Rescue on Fractalus. Now I apologize, I'll have to lower the volume on this because my capture device will be picking up the audio for this. Even though I've made the changes and adjustments so that it looks correct and it doesn't have weird stuff going on, I want you to see something with the game Rescue on Fractalus, and this is kind of true of a lot of 5200 games. So here we are looking at the main title screen, and you're going to notice two things. One is that we have this space over here to the far left, which has this little area that's black off to the side of the green level select area, and this blue section over here that seems kind of out of place. And then over here on the right hand side, what's going on over here? We've got all these weird scrambly pixels going on. There's nothing wrong with the console, there's nothing wrong with the Lumacode at all. This is perfectly normal. 5200, the Atari 8-bit, their display outputs actually have additional graphic data that was not normally seen back in the day because it got cut off on the CRT tube. This is information that's always present but was in the overscan, so you didn't see it. Well, if you don't mind and you're fine with this kind of thing, then you can just continue to play and use the console and you're good to go. But you might be bothered by this. Well, luckily the RGB to HDMI does give us some configuration changes we can make to help with this. So again, I'm going to hit SW1 to access the menu, and this time I'm going to go into the geometry menu. There's probably other ways to do what I'm about to show you, but this is the way I've been doing it. So if I go into the max horizontal width, which defaults to 384, I'm going to hit enter to make a change on this. Then as I start to lower that value, it starts to shrink in the sides of the image. And you'll see that when I back out of this, we no longer have the extraneous data that we saw over here before or over here off to the right hand side, and now it looks more correct. Now that I've made these changes, this isn't something you're going to want to keep doing every single time, right? You're going to want to make these changes once and then have it always come up that way. Well, you're in luck. If you go into the menu and you take a look at about the middle of your menu options, there is a Save Configuration option. And when you're highlighted on that, or when you have that selected and you hit the menu button, it's going to save whatever the current configuration settings you have in place to the current profile you have selected. So as you can see, it says that it saved the Atari 5200 Lumacode and saved it as a new 5200 60 Hz setup. So now the next time that I go in and load up this particular profile, it will already remember these settings and be good to go. Another cool feature that you might want to know about is, let's say you've gotten a new high score in a game and you're particularly proud of it and you want to kind of show that off. Well, keep in mind that the RGB to HDMI has a micro SD card in it, and it has to have that in order to load up its operating system and the software. But that also gives you something else. Turns out that if you just push the SW2 button once really quick, it will actually do a screen capture of what you're currently looking at on the screen and saves that as a picture file in its own folder for that profile on the SD card. In fact, if I were to take the SD card and take a look at it on a computer, there will be a folder called Captures, and when I open it, it will have a separate subfolder in it that matches each of the consoles that I have taken screen captures for. Makes it real nice for both troubleshooting purposes and, again, to kind of show off high scores and just to show off the quality of the output that you get from this particular setup. That's the basics of how to use the RGB to HDMI. There's of course a gazillion other options and configurations that this little box allows you to cycle through and adjust the image that might best suit your needs, and you will find that some of these options you're going to have to go into, especially changing the profile if you're using multiple consoles with the device, as I was here, but also you're going to find that between different displays and different profile types, you may have to adjust the geometry settings a little bit, and you may even have to go into the phase or the sampling section and make some changes there. So thank you again for joining me here at the Ivory Tower. I hope that this video is somewhat informative and helpful to you. Again, there's a whole lot of other options on the RGB to HDMI than what I've covered here. I'll try to put links down in the video description so that you can peruse those and kind of look at the information on your own to get a better understanding. So with that, I'll catch you guys another time. Keep gaming.